Welcome back, my dear students. In our previous class, we have solved one problem. And what was the answer you got? Did you get R is equal to 18 ohm? I hope everyone got the same. Shall we solve the next problems? Yes. First problem. A uniform copper wire of length 2 meter, area of cross section 5 into 10 to the power minus 7 meters square, carries a current of 2 ampere, assuming that there are 8 into 10 to the power 28 free electrons per meter cube of copper. Calculate the drift velocity of electrons. How much time will an electron take to drift from one end of the wire to the other? Correct? This is the question. Okay. See here, a uniform cross section. What is the length? Let us write the length. 2 meter. Area of cross section 5 into 10 to the power minus 7 meter square. Carries the current I is equal to 2 ampere. Assuming that there are number of electrons it is given, correct? How many? 8 into 10 to the power 28 free electrons per unit volume it is. Correct? That is, so shall I write like this? Okay. So I have to write per meter cube. Then what is given? No need, I have written V, no? So enough. Next what I have to write is, you have to calculate the drift velocity and time. How to calculate? How to calculate? See here, I said number of electrons per unit volume it is given, correct? So here, why I wrote this is for your reference. What the N we have taken in the formula is number of molecules or number of electrons per unit volume itself. I have to calculate VD. We know that I is equal to NEAVD, correct? So can I calculate VD like this? I by NEA. Because I know N, I know E, I know A, I know I. So if we substitute, what do we get? 2 divided by 8 into 10 to the power 28. Charge of the electron, 10 to the power minus 19. Then area of cross section, how much? 5 into 10 to the power minus 7. What is the answer you get here? Take your calculator and calculate. What is the answer you are getting? What is the answer you are getting? Are you getting 3.125 into 10 to the power minus 4? 3.125 into 10 to the power minus 4 meter per second. Are you getting the same? Okay. Next, you have to calculate the time. How to calculate the time? We know that velocity is equal to distance by time. So VD is equal to length by time. I know that, correct? For a conductor. So can I calculate T is equal to L by VD? Substitute. L length is given. VD we got it. 3.125 into 10 to the power minus 4. What is the answer you are getting? What is the answer you are getting? Can you help me? What is the answer? Are you getting 6.4 into 10 to the power 3? 6.4 into 10 to the power 3 seconds. 6.4 into 10 to the power 3 seconds. Yes. This is how you have to calculate the current and drift velocity. Shall I go for the next question? Yes. Here is the next question. A current of 2 ampere is passing through a metal wire of cross-sectional area 2 into 10 to the power minus 6 meters square. Okay, area of cross-section is given. If the number density of the free electrons in wire is 5 into 10 to the power 26 per meter cube, find the drift velocity of the electron. And what you have to calculate? Only drift velocity you have to calculate, nothing more. See, current is given, area of cross section is given, n. Number density means n, it is given, and electrons, charge of the electron is given. So you have to, you know that, correct? You have to calculate Vd. The same method, Vi is equal to NEA Vd. So I am not going to solve this problem, it is homework. Okay, second problem is homework. Next, shall I go for the next problem? Yes. A copper wire has a diameter 2 millimeter and the wires carries current. Wires carries a current, constant current 3 ampere. Assuming the density of the electrons to be 8.5 into 10 to the power 28 meter cube per meter cube, find the magnitude of current density and drift velocity. Current density is nothing but J, correct? Okay, third question. Diameter is given 2 millimeter. Where is the wire of the current? 3 ampere. Assuming density of the electrons. Density of the electron is nothing but here number density 80.5 into 10 to the power 28 per meter cube. Correct? Find the current density and drift velocity. What is given? We know that J is equal to I by A. But area is not given, correct? So how to calculate the area? But diameter is given. So what I can do? Which formula I can use for area? Area is nothing but pi r square, correct? That is area of cross section. So 3 by pi r square. What is r? R is equal to d by 2 is equal to 2 into 10 to the power minus 3 divided by 2. That is 1 into 10 to the power minus 3 meter, correct? So what I get? 3 divided by 3.14 into 1 into 10 to the power minus 3 the whole square. What is the answer you are getting for current density? Can you help me? What is the answer you are getting? Are you getting 9.55 in 10 to the power 5? (9.55) into 10 to the power 5 ampere per meter square. Correct? Next, what you have to calculate? You have to calculate the drift velocity. Direct I is equal to NEA Vd. Correct? Vd is equal to I by NEA. 8.5 into 10 to the power 28. 1.6 into 10 to the power minus 19. Area. Correct? 1 into 10 to the power minus 3. What is the answer you are getting? Can you help me? What is the answer you are getting? Instead of this, see here, I by A, you know it, however. So, can you write it like this? Can we write it like this? Yes. Because I by A is nothing but this one, correct? What is the answer you're getting? What is the answer? Is it 7.02 into 10 to the power minus 5? 7.02 into 10 to the power minus 5 meter per second. Are you getting the same? Yes. We'll go for the next question. Question number 4. A copper wire of 10 to the power minus 6 meters square cross-sectional area carries the current of 2 ampere. If the electron density is 8 into 10 to the power 8, what is the current density and average drift velocity? Can you calculate on your own? Same method. So it is homework. So question number 4, homework. Question number 2, homework. Okay. Next. 6.25 into 10 to the power 18 electrons flow through a given cross section in unit time. What is the current? So number of electrons flowing through a cross section in unit time it is given. Time is 1 second, correct? You have to calculate the current. I is equal to Q by T. But we don't know Q. Because for one electron we know. There are how many electrons here? 6.25 10 to the power 18 electrons. So what is the amount of current it is asked? How to calculate? See, this question is very important for 1 mark. Okay. Question number 5 is very, very, very important for 1 mark. But what is Q? Can I write Q is equal to NE? So I is equal to NE by T. Substitute. What is the answer you are getting? Approximately equal to 1 ampere. Approximately equal to 1 ampere. Understood? Understood? Shall I go for the next question? Next, question number 6. Resistance of a copper wire is 0.5 ohm. Correct? Its length is 5 meter. Diameter is 0.05 centimeter. What is the resistivity? Correct? Rho you have to calculate. R, what is the relation between R and rho? R is equal to rho L by A. Do we have R? Yes. L? Yes. Area, can we calculate? Yes, we can calculate by using area of cross section is nothing but pi R square, correct? So, am I right? Calculate. What is the answer you are getting? 0.025 into 10 to the power minus 2 meter. So rho is equal to RA by L. 0.5 into area pi R square. Calculate. What is the answer? What is the answer? Are you getting 1.9625? Are you getting 1.9625 in 10 to the power minus 8 ohm meter? Please use the calculator, not the scientific calculator, ordinary calculator. Okay. Shall I move for the next problem? Yes. Question number 7. Resistance of a conductor is 6.5 ohm. Okay. Then what is given? At 60 degrees Celsius, temperature is 60 degrees Celsius. Okay. Then what is given? And 7.7 ohm at 100 degrees Celsius. Okay. Then what is given? Calculate the temperature coefficient of resistivity of the material of the conductor. That is, you have to calculate alpha. How to calculate alpha? Alpha is equal to R2 minus R1 by R2 T R1. Okay, sorry. R1 T2. Am I right? Is this a formula? Use it and calculate. Calculate. Which one will take it as temperature 1 and 2? Which one shall we take? R2 is equal to, we'll take this one as second one. First one. Okay. R2 minus R1 divided by R1 into temperature T2 minus 6.5 into, what is the answer? Can you help me for the answer? What is the answer you are getting? 6.38 into 10 to the power minus 3. Per degree Celsius. See, you can convert also or you can keep it as it is. Now I have kept it as it is. So the unit is per degree Celsius. If you have converted temperature from Celsius to Kelvin, then you have to write per Kelvin. Understood? Next. Shall I move further? Yes. Next problem. Find the resistance between A and B in the following circuit. Okay, we'll draw that circuit once. Question number 8. A and A, then where is B? B and C. Okay. I 8 ohm 6 3 I1 and I2. Correct? This is your diagram. Fine. You have to calculate the resistance between A and B. Resistance between A and B of the following circuit. What is that resistance between the A and B? I think it is not A and B, it is A and C, correct? I'm sorry. Resistance between A and C. Okay. So total resistance. But these two resistors are connected in parallel. This in single, it is connected with these two in series. So first, just like how you calculated in capacitor, first what you have to do, calculate the equivalent resistance of these two. That is parallel. Then you calculate with the series. What is the formula to calculate parallel? Rp is equal to 1 by R1 plus 1 by R2. Correct? 1 by Rp is equal to 1 by 6 plus 1 by 3. Calculate. What is the answer? 6. 1 plus 2. That is 3 by 6. 3 ones are, 3 twos are. 1 by Rp is equal to 1 by 2, or Rp is equal to 2 ohm. Correct? Next, what you have to calculate? Series. Correct? Rs is equal to R1 plus Rp. Am I right? Next, R1 is how much? Shall I mark this one as R1, R2, R3 so that you will understand which is R1, R2. So here I have to calculate R2 and R3. R2 and R3. Here R1, 8 plus 2, 10 ohm. Correct? 10 ohm. So the resistance between A and C is 10 ohm. Understood? Simple circuit it is. Now it is very easy. As you go further, the circuit becomes little bit complicated and complicated. Then you will have to redraw this diagram. How to redraw this diagram according to your problem have you solved? See, first step, what you have solved? Came like this. A, B, C. Because now this is R1. How much it is? 8 ohm. Now this is Rp is equal to 2 ohm. Correct? Finally, how it is? A and C, it became 10 ohm. Like this. Correct? This diagram, second step this diagram, third step this diagram. This is how, to understand yourself, I have drawn this. No need to draw this and all. Just for your reference, I have drawn this. Understood? Shall I move further? Yes. Next. Now what you have to do is, you have to find the resistance between the following circuit, correct? One more diagram, question number 19. Sorry, 9. Sorry, question number 9. I'll draw the diagram. Then correct? Shall I mark it now? 1 ohm, 1 ohm. Oh, everywhere it is 1 ohm. Fine. It's easy for me to write. A, B. Correct? Find the resistance between A and B of the following. resistance between A and B after connecting all this. How to find equivalent resistance? How to find? See here, these two are connected in a series. Am I right? Shall I use a color chalk? I'll use those two now. Okay? R1 plus R2. So what I'll get? 1 plus 1 is equal to 2 ohm. Now what is the second step? Shall I redraw it? So that it will be easy. How the diagram is now? This is like that itself. This is also same. Now this 2 become as 1. Correct? It has become 1 now. I'll mark it now. 1 ohm. A is here. B is here. 1 ohm. 1 ohm. And this is now 2 ohm. Correct? 2 ohm. Now look here. These two are in parallel. Correct? These two are in parallel. So I have to use R1 plus 1 by R2. Shall I substitute? 1 by 1 plus 1 by 2. 2 plus 1, that is 3 by 2. Rp is equal to 2 by 3 ohm. Am I right? Am I right? Next. What is the next step? Shall I draw the diagram here? Here I am drawing the third diagram. How the diagram is now? This is as it is. This is also as it is. These two has become now 1. How much is this? 2 by 3 ohm. A, B. Correct? 1 ohm. This is 1 ohm. Okay, for this, I have to calculate between A and B. How to calculate? Now these two are in parallel or series? These two are in parallel or series? This is one end is connected to the other, but this end is not connected to each other. So it is series, correct? So RS is equal to again R1 plus R2. So which is R1 now? Anyone. 2 by 3 plus 1. That is 2 plus 3 by 3. That is 5 by 3 ohm. Correct? What is the next step now? Next step, total resistance. How this now? What is the next diagram which I can draw? This is as it is. This one and this one became like this, parallel now. Correct? Correct? Or else, for your easy reference purpose, I'll draw it again this. Fine. This is 1 ohm A, B. How much is this one? 5 by 3 ohm. Correct? Now how to calculate? These two are in parallel now. See? End to end connection. So 1 by Rp is equal to 1 by R1 plus 1 by R2. 1 by 1 plus 5 by 1 by 5 by 3. Correct?